All right, well, thank you all for coming. We'll go ahead and kick off the webinar now, and I'm sure people will continue to stream in. Um, I'm Lance, I'm one of the founding engineers at LangChain, and I'm joined by Peak from Manus. Peak, do you want to introduce yourself quickly?
Yeah, hey guys, I'm the co-founder and chief scientist of Manus. So basically, I've designed the agent framework and a lot of things in Manus, and I'm super excited to be here today. Thanks, Lance, for having
Y-
me.
Yeah, we're really excited to do this because Manus is a really cool product. I've been using it for a long time, but also they put out a really nice blog post on context engineering a few months ago that influenced me a lot. So I want to give a quick overview of context engineering as I see it, and I'll reference their piece. And then Pete's actually going to give a presentation talking about some new ideas not covered in the piece. So if you've already read it, he needs to cover some things that are new, which will hopefully be quite interesting for you. But I'll just kind of set the stage and I'll hand it over to Pete, and then we'll do some Q&A. So you might have heard this term, context engineering, and it kind of emerged earlier this year. If you look through time with Google search trends, prompt engineering was kind of initiated following ChatGPT. So that's showing December 2022. And when we got this new thing, a chat model, there became a great deal of interest in how do we prompt these things. Prompt engineering kind of emerged as a discipline for working with chat models and prompting them. Now, context engineering emerged this year around May. We saw it really rise in um, Google Trends. And it corresponds a bit with this idea of the year of agents. And so why is that? One of the things that people have observed, if you've been building agents, is that context grows. And it grows in a very particular way. When you build an agent, what I mean is we have an LLM bound to some number of tools. That LLM can call tools autonomously in a loop. The challenge is for every tool call, you get a tool observation back, and that's appended to this chat list. These messages grow over time. And so you can kind of get this unbounded explosion messages as agents run. As an example, Manus talked about in their piece that typical tasks require around 50 tool calls. Anthropics mentioned similarly that production agents can engage in conversations spanning hundreds of turns. So the challenge is that agents, because they are increasingly long running and autonomous, they utilize tools freely, you can accumulate a large amount of context through this accumulation of tool calls. And Chrome will put out a really nice report talking about context rot. The observation simply is that performance drops as context grows. So you have this paradox, so you have this challenging situation. Agents utilize lots of context because of tool calling, but we know that performance drops as context grows. So this is a challenge that many of us have faced, and it kind of spearheaded this, or I think seeded this term of context engineering. Karpathy, of course, kind of coined it on Twitter earlier this year. And you can think about context engineering as the delicate art and science of filling the context window with just the right information needed for the next step. So trying to combat this context explosion that happens when you build agents and they call tools freely, all those tool messages accumulate in your messages queue, how do we kind of cull such that the right information is presented to the agent to make the correct next decision at all points in time? So to address this, there's a few common themes I want to highlight that we've seen across a number of different pieces of work, including Manus, which I'll mention here. Idea one is context offloading. So we've seen this trend over and over. The central idea is you don't need all context to live in this messages history of your agent. You can take information and offload it, send it somewhere else. So it's outside the context window, but it can be retrieved, which we'll talk about later. So one of the most popular ideas here is just using a file system. Take the output of a tool message as an example, dump it to the file system, send back to your agent just some minimal piece of information necessary so it can reference the full context if it needs to, but that full payload, for example, web search result that's very token heavy, isn't spammed into your context window for perpetuity. So we've seen this across a number of different projects. Manus uses this. We have a project called Deep Agents that utilizes the file system. Open Deep Research utilizes actually agent state, has a similar role to an external file system. Claude Code, of course, uses this very extensively. Long-running agents utilize it very extensively. So this idea of offloading context to a file system is very common and popular across many different examples of production agents that we're seeing today. The second idea is reducing context. So offloading is very simply taking some piece of information like a tool message that's token heavy and not sending it all back to your messages list, dumping it to a file system where it can be retrieved only as needed. That's offloading. Reducing the context is similar, but instead, you're just summarizing or compressing information. Summarizing tool call outputs is one intuitive way to do this. So we do this with Open Deep Research as an example. Pruning tool calls or tool messages. One thing that's very interesting is Claude 4.5 has actually added this too. If you look at some of their most recent releases, they now support this out of the box. So this idea of pruning old tool calls with tool outputs or tool messages is something that Claude is now kind of built into their SDK. Summarizing, compacting full message history. You see this with Claude Code in its compaction feature once you hit a certain percentage of your overall context window. Cognition also talks about the idea of summarizing or pruning at agent-to-agent handoffs. So this idea of reducing context is a very popular theme we see across a lot of different examples, from Claude Code to our Open Deep Research, Cognition. Claude 4.5 has incorporated this as well. Retrieving context. Now, this is one of the classic debates today that you might see raging on X or Twitter. The right approach for retrieving context. Lee Robinson from Cursor just had a very nice talk, and I'll make sure these slides are all shared so you can see these links. He had a very nice talk at OpenAI Demo Day, talking about Cursor, for example, uses indexing and semantic search, as well as more kind of simple file-based search tools like glob and grep. Claude Code, of course, only uses the file system and simple search tools, notably glob and grep. So there's different ways to retrieve context on demand for your agent. Indexing and something like semantic search, file system, and simple file search tools. Both can be highly effective. There's pros and cons we could talk about in the Q&A. But of course, context retrieval is central for building effective agents. Context isolation is the other major theme we've seen quite a bit of. In particular, splitting context across multi-agents. So what's the point here? Each subagent has its own context window, and subagents allow for separation of concerns. Manus wide agents talks about this. Our deep agents work uses this. Open Deep Research uses it. Claude subagents are utilized in their research. Subagents are utilized in Claude's research, Claude's multi-agent researcher, and also Claude Code supports subagents. So these are all so subagents are a very common way to perform context isolation we've seen across many different projects. Now, one thing I thought was very interesting is caching context. And Manus talks about this quite a bit. And I'll let Peak speak to this a bit later, but I think it's a very interesting trick as well. So I'll just show a brief example that we've seen across Open Deep Research. This is a very popular repo that we have. It's basically an open source deep research implementation. It performs on par with some of the best implementations out there. You can check our repo. We have results from Deep Research Bench showing that we're top 10. It has 3 phases: scoping of the research phase itself using a multi-agent basically architecture, and then a final one-shot writing phase. We use offloading. So we basically create a brief to scope our research plan. We offload that. So we don't just save that in the context window, because that context window is going to get peppered with other things. We offload it so it's saved independently. It can be accessed, in our case, from the LangGraph state, but it could also be from the file system. It's the same idea. So you create a research plan, you offload it so it's always accessible. You go do a bunch of work. You can pull that back in on demand, so you can put it kind of at the end of your message list so it's accessible and readily available to your agent to perform, for example, the writing phase. We use offloading, as you can see, to help steer the research and writing phases. We use reduction to summarize observation from token-heavy search tool calls. That's done inside research itself. And we use context isolation across subagents within research itself. And this is kind of a summary of a bunch of different of these various ideas across a bunch of different projects. And actually, Peak is going to speak to Manus in particular and some of the lessons they've learned. So this just kind of sets up the stage, and this just kind of summarizes what I talked about. These different themes of offloading, reducing context, retrieving context, isolating, caching, and a number of popular projects and kind of where they're used. and a few different links. I will share these slides to the notes, and I do want to let Peak go ahead and present now because I want to make sure we have plenty of time for him and for questions. But that just sets the stage, and Peak, I'll let you take it from here. I'll stop sharing.
Okay, can you see my slides?
Yep.
Okay, perfect. Okay, thank you, Lance. I'm super excited to be here today to share some fresh lessons on context engineering that we learned from building Manus. Here I say fresh lessons because I realized that the last blog post that you mentioned I wrote about context engineering was back in July. And yeah, it's the year of the agent, so July is basically the last entry. And of course, before this session, I went back and read it again. And luckily, I think like most of what I wrote in that blog still holds up today. But I just don't want to like waste everybody's time by like just repeating what's already inside that blog. So today, I think instead I want to dig into some areas that I either didn't go deep enough on before or didn't touch at all. So actually, we'll be focusing on the discourage column in Lance's earlier slides because personally, I think exploring those non-consensus ideas often leads to the biggest inspirations. Yeah. So here's the topic for today's talk. First, we'll cover a bit about the bigger question of why we need context engineering. And then we'll have more on context reduction, more on context isolation, and finally some new stuffs about context offloading, which we are testing internally here at Manus. Yeah, so everything I'm sharing today is in production in Manus. It's battle tested, but I don't know how long it will last because things are changing super fast. Okay, let's start with the first big question is why do we even need context engineering? Especially, when fine-tuning or post-training models has become like much more accessible today. Yeah, for example, folks at the Thinking Machine team, they just released the Tinker API, which I like a lot, beautiful design. But for me, the question like why context engineering actually came through several painful stages of realization. Before starting Manus, I've already spent over 10 years in natural language processing or NLP, which is basically what we call building language models, but before ChatGPT. And Manus is actually my second or third company. At my previous startup, we trained our own language model from scratch to do open domain information extraction and building knowledge graph and semantic search engines on top of them. And it was painful. Our product's innovation speed was completely capped by the model's iteration speed. Even back then, the models were much smaller compared to today. But still, a single training plus evaluation cycle could take maybe like 1 or 2 weeks. And the worst part is that at that time, we hadn't reached PMF yet. And we're spending all that time like improving benchmark that might not even matter for the product. So I think instead of building specialized models too early, startups really should lean on general models and context engineering for as long as possible. Well, of course, I guess now that's some kind of common wisdom, but as your product matures and open source based model gets stronger, I know it's very tempting to think, hey, maybe I should like just pick a strong base model, fine tune it with my data, and make it really good at my use case. We've tried that too. And guess what? It's another trap. To make RL work really well, you usually fix an action space, design a reward around your current product behavior, and generate tons of like on policy rollouts and feedback. But this is also dangerous because we're still in the early days of AI and agents. Everything can shift under your feet overnight. For us, the classic example was the launch of MCP. Actually, it completely changed the design of Manus from a compact, static action space to something like it's infinitely extensible. And if you have ever trained your own model, you know that this kind of open domain problem is super hard to optimize. Well, of course, you could like pour massive effort into post-training that ensures generalization, but then aren't you basically trying to become an LM company yourself? Because you're basically rebuilding the same layer that they have already built, and that's a duplication of effort. So maybe after all that buildup, here's my point. Be firm about where you draw the line. Right now, context engineering is the clearest and most practical boundary between application and model. So trust your choice. All right, enough philosophy, and let's talk about some real tech. First topic, context reduction. Here I want to like clarify two different kinds of compaction operations because we think like context reduction is fascinating, but it's also a new concept. There's a lot of way to do this. And here in Manus, we divide them into compaction and summarization. For compaction, in Manus, every tool call and tool result, we actually has two different formats, a full format and a compact one. The compact version strips out any information that can be like reconstructed from the file system or external state. For example, here, let's say you have a tool that writes to a file, and it probably has two fields, a path and a content field. But once the tool returns, you can ensure that the file already exists in the environment. So in the compact format, we can safely drop the super long content field and just keep the path. And if your agent is smart enough, well, like whenever it needs to read that file again, it can simply retrieve it via the path. So no information is truly lost. It's just like externalized. We think this kind of like reversibility is crucial because agents do like chain predictions based on previous actions and observations. And you never know like which past action will suddenly become super important like 10 steps later. You cannot predict it. So this is a reversible reduction by using compaction. Of course, like compaction only takes you so far. Eventually, like your context will still grow and will hit the ceiling. And that's when we combine compaction with the more like traditional summarization, but we do it very carefully. For example, here before summarizing, we might offload key parts of the context into files. And sometimes, like we even do more aggressively. We can dump the entire pre-summary context as a text file or simply a log file into the file system so that we can like always recover it later. And like Lance like just mentioned, some people just use like glob and grep. Glob and grep also works for log files. So if the model is smart enough, it even knows how to retrieve those like those pre-summarized contexts. Yeah. So I think the difference here is that compaction is reversible, but summarization isn't. Both reduce context lengths, but they behave very differently. And to make these to make both methods coexist, we have to track some like context length thresholds. At the top, like you'll have your model's hard context limit. Say like 1 million tokens pretty common today, but in reality, most models start degrading much earlier, typically maybe around 200K. And you'll begin to see what we call a context rot. It's like repetitions, slower inferences, degraded quality. So by doing a lot of the evaluation, it's very important for you to identify that pre-rot threshold. It's typically 128K to 200K and use it as the trigger for context reduction. And whenever like your context size approaches it, you have to trigger a context reduction, but starting from compaction, not summarization. And compaction doesn't mean like compressing the entire history. We might compact, say, like the oldest 50% of tool calls while keeping the newer ones in full detail. So the model still has fresh few-shot examples of like how to use tools properly. Otherwise, like in the worst case, the model will imitate the behavior and output those compact format with missing fields. And that's totally wrong. And after compaction, we have to check how much free context that we actually gain from this like compaction operation. Sometimes, like in this graph, after multiple rounds of compaction, the gain is tiny because like even if compact, it still uses context. And that's when we go for summarization. But also keep in mind that when summarizing, we always use the full version of the data, not the compact one. And we still like keep the last few tool calls and tool results in full detail, not summary, because it can allow the model to know where it left off and will continue like more smoothly. Otherwise, you'll see like after summarization, sometimes the model will change its style, change its tone. And we find out like keeping a few like tool call and tool result examples really help. Okay, now we've covered reduction, and let's talk about isolation. I really agree with Cognition's blog where they warn against using multi-agent setups because, like, when you have multiple agents, syncing information between them becomes a nightmare. But this isn't a new problem. Multi-process or multi-thread coordination has been a classic challenge in the early days of computer programming, and I think we could borrow some wisdoms here. I don't know how many like Golang coders here are here today, but in the Go programming language community, there's a famous quote from this gopher: "Do not communicate by sharing memory. instead share memory by communicating. Of course, this isn't directly about agent, and it's sometimes even wrong for agents. But I think the important thing is it highlights two distinct patterns here, which is by communicating or by sharing memory. But if we translate the term memory here into context, we can see that parallel pretty clear. By communicating is like the easier one to understand because it is the classic sub-agent setup. Here, for example, the main agent writes a prompt, and the prompt is sent to a sub-agent, and the sub-agent's entire context only consists of that instruction. We think if a task has a like short, clear instruction and only the final output matters, say like searching a code base for a specific snippet, then just use the communication pattern and keep it simple. Because the main agent doesn't care how the sub-agent find the code. It only needs the result. And this is what like Claude Code does typically using its like task tool to delegate like separated clear tasks to some sub-agents. But for more complex scenarios, in contrast, by sharing memory means that the sub-agent can see the entire previous context. It means like all the tool usage history. But the sub-agent has its own system prompt and its own action space. For example, like imagine a deep research scenario. The final report depends on a lot of intermediate searches and notes. And in that case, you should consider using the shared memory pattern, or in our language, by sharing context. Because like even you can save all that notes and searches into file and making the sub-agent to read everything again. But you're just wasting latency and context. And if you count the amount of token, maybe you're using even more token to do this. So we think like for those scenarios that requires a full history, just use a shared memory pattern. But be aware that like sharing context is kind of expensive because each sub-agent has a larger input to prefill, which is like you'll spend more on like input tokens. And since the system prompt and the action space differs, you cannot reuse the KV cache, so you have to pay the full price. And finally, let's talk a little bit about like context offloading. When people say offload, they usually mean like moving parts of the working context into external files. But as your system grows, especially if you decide to integrate MCP, one day you realize that the tools themselves can also take up a lot of context. And having too many tools in context leads to confusion. We call it context confusion. And the model might call like the wrong ones or even like non-existing ones. So we have to find a way to also offload the tools. A common approach right now is like doing dynamic RAG on tool descriptions. For example, like loading tools on demand based on the current task or the current status. But that also causes two issues. First of all, like since tool definitions sit at the front of the context, yeah, your KV cache resets every time. And most importantly, the model's past calls to remove tools are still in the context. So it might few shot the model into like calling invalid tools or using invalid parameters. So to address this, we're experimenting with a new layered action space in Manus. Well, essentially, we can let Manus to choose from 3 different levels of abstractions. Number 1, function calling. Number 2, sandbox utilities. And number 3, packages and API. We'll go deeper into these 3 layers of layered action space. Let's start from level 1, function calling. And this is a classic. Everyone knows it. It is schema safe thanks to constraint decoding, but we all know the downsides. For example, we mentioned like breaking the cache, and maybe too many tool calls will cause some confusion. Too many tools may cause confusion. So in Manus, right now, we only use a fixed number of atomic functions. For example, like reading and writing files, executing shell commands, searching files in internet, and maybe some like browser operations. We think these atomic functions have super clear boundaries, and they can work together to compose like much more complex workflows. Then we offload everything else to the next layer, which is the sandbox utilities. As you know, each Manus session runs inside a full virtual machine sandbox. It's running on our own customized Linux system. And that means Manus can use the shell commands to run pre-installed utilities that we developed for Manus. For example, we have some format converters, we have like speech recognition utilities, and even a very special, we call it Manus MCP CLI, which is how we call MCP. We do not inject MCP tools to the function calling space. Instead, we do everything inside that sandbox through in the command line interface. And utilities are great because like you can add new capabilities without touching the model's function calling space. And it's just some like commands pre-installed in your computer. And if you're familiar with Linux, you always know how to find those new commands. And you can even run like dash dash help to figure out how to use a new tool. And another good thing is for larger outputs, they can just write to files or return the result in pages. And you can use all those Linux tools like grep, cat, less, more, like to process that result on the fly. So the trade-off here, like it's super good for large outputs, but it's also not that good for low latency back and forth interactions with the front end because like you always have to like to visualize the interactions of your agent and show it to the user. So this is pretty tricky here, but we think like it already offloads a lot of things. And then we have another layer, the final layer, we call it packages and APIs. Here Manus can write Python scripts to call pre-authorized API or custom packages. For example, like Manus might use a 3D designing library for modeling or call a financial API to fetch market data. And here, actually, like we've purchased all these API on behalf of our user and pay the money for them. It's included in the subscription. So we have a lot of like API keys pre-installed in Manus, and Manus can access these APIs using the keys. I think these are perfect for tasks that requires lots of computation in memory, but do not need to push all that data into the model context. For example, like imagine if you're analyzing a stock's entire year of price data, you don't feed the model all the numbers. Instead, you should let the script to compute it and only put the summary back into the context. And since code and APIs are super composable, you can actually chain a lot of things in one step. For example, like in a typical API, you can do like get city names, get city ID, get weather, all in one Python script. There's also a paper like from one of my friends called Code Act. A lot of people were like discussing about it. I think it's like the same idea because like code is composable and it can like do a lot of things in one step. But also it's like it's not schema safe. It's very, very hard to do like constraint decoding on Kodak. So we think you should find the right scenario for these features. For us, we use all, as we mentioned, everything that's like that can handle inside a like compiler or interpreter runtime. We do that using code. Otherwise, we use like sandbox utilities or function calls. And the good thing is, if you have these three layers, from the model's point, all three levels still go through the standard function calls. So the interface stays simple, cache-friendly, and orthogonal across functions. Because we mentioned sandbox utilities. You're still accessing these tools using the shell tool, accessing these tools using the shell function. And also, like if you're using APIs and third-party applications, you're just using the file function to write or read file and then execute it using the shell function. So we think it does not add add overhead to the model. It's still all the things that models are trained and they're already familiar with. So let's zoom out and connect the 5 dimensions: offload, reduce, retrieve, isolate, and cache. You can find out that they are not independent. We can see that offload and retrieve enables more efficient reduction, and stable retrieve makes isolation safe. But isolation, oh yeah, isolation also slows down context rows and reduces the frequency of reduction. However, more isolation and reduction also affects cache efficiency and the quality of output. So at the end of the day, I think context engineering is the science and art that requires a perfect balance between multiple, potentially conflicting objectives. It's really hard. All right, before we wrap up, I want to leave you with maybe one final thought. And it's kind of the opposite of everything I just said, which is please avoid context over engineering. Like looking back at the like past 6 or 7 months since Manus launch, actually the biggest leap we've ever seen didn't came from like adding more fancy context management layers or clever retrieval hacks. They all came from simplifying or from like removing unnecessary tricks and trusting the model a little more. Every time we simplified the architecture, the system got faster, more stable, and smarter. Because we think context engineering the goal of context engineering is to make the model's job simpler, but not harder. So if you like take one thing from today, I think it should be build less and understand more. Well, thank you so much, everyone. And thanks again to Lance and the LangChain team for having me. Can't wait to see what you guys all build next. Now back to Lance.
Yeah, amazing. Thank you for that. Um, so we have a nice set of questions here. Maybe we can just start hitting them and we can kind of reference back to the slides if needed. And Peak, are your slides available to everyone?
Oh,
Um,
yeah. Yeah, I can share the PDF version afterwards.
yes, sounds good. Um, yeah, why don't I start looking through some of the questions and maybe we can start with the more recent ones first. Um, so how does the LM call the various shell tools? How does it know which tools exist and how to invoke them? Maybe you can explain a little bit about kind of the multi-tier kind of sandboxing setup that you use with Manus.
Yeah, I think like imagine you're the person that using a new computer. For example, if you know Linux, you can imagine like all the tools are located in /usr/bin. So we do two things. First of all, we have a hint in the system prompt telling Manus that, hey, there's a lot of pre-installed command line utilities located in some specific folder. And also like for the most like frequently used ones, we already like injected in the system prompt, but it's super compact. We do not like tell the agent how to use the tools. We only list them, and we can tell the agent that you can use the dash dash help flag safely because all the utilities are developed by our team and they have the same format.
Got it. How about I know you talked a lot about using file system. What's your take on using indexing? And do you utilize like do you spin up vector stores on the fly if the context you're working with gets sufficiently large? How do you approach that?
Yeah, I think like there's no right and wrong in this space, like you've
Yeah.
mentioned. But at Manus, we do not use index databases because right now, every sandbox in Manus session is a new one, and users want to like interact with things fast. So actually, we don't have the time to like build the index on the fly. So we're
Yeah.
more like Cloud Code. We rely on like grep and glob. But I think like if you like consider to build something like more long-term memory, or like if you want to integrate some like enterprise knowledge base, you still have to rely on that like external vector index because like it's only about the amount of information that you can access. But for like Manus, like it operates in a sandbox, and for coding agent, you operate in the code base. So it depends on the scale.
Yeah, so that's a good follow-up then. So let's say I'm a user, I have my Manus account, I interact with Manus across many sessions. Do you have the notion of memory? So Claude has Claude MD files, they persist across all the different sessions of Claude code. How about you guys? How do you handle kind of long-term memory?
Yeah, actually in Manus we have a concept called knowledge, which is kind of like explicit memory. For example, like every time you can tell Manus, hey, remember like every time I ask for something, deliver is in maybe in Excel. And it's not automatically inserted into some memory. It will pop up a dialogue and say, here's what I learned from our previous conversation, and would you like accept it or reject it? So this is the explicit one. It requires user confirmation. But also like we are discovering new ways to do it more automatically. For example, like a pretty interesting thing in agents is that like compared to chatbots, user often like correct the agent more oftenly. For example, like a common mistake that Manus make is when doing like data visualization. If you're using Chinese, Japanese, or Korean, a lot of time there will be some font issues. There'll be errors in those render visualizations. So the user will often say like, "Hey, you should like use like Nodo Sans CJK font." And for these kind of things, the user the different user will have the same correction. And we need to maybe to find out a way to like to leverage these kind of like collective feedback and use it as kind of like we call it self-improving agent with online learning, but in a parameter-free way.
Yeah. How about a different question that was raised here and also I think about quite a bit? You mentioned towards the end of your talk that you gained a lot from removing things. And
Yeah.
a lot of that is probably because of the fact that also the models are getting better. So model capabilities increasing, and so you can kind of remove scaffolding over time. How do you think about this? Because this is one of the biggest challenges that I've faced is like over time, the model gets better and I can remove things like certain parts of my scaffolding. So you're building on top of this, the foundation that's like the water's rising. And like, do you revisit your architecture every some number of months with new releases and just delete as the models get better? And how do you approach that problem?
Yeah, this is a super good question here because Actually, we have already refactored Manus for 5 times, and we've launched Manus in March, and now it's October already 5 times. So we think like you cannot stop because like models are not only improving, but they are changing. Models'
Yeah.
behavior are changing over time. Like one way is you can work closely with those like model providers, but we also have another like internal theory for how we evaluate or how we design our agent architecture. I've heard it a little bit on Twitter before. It's basically like we do not care about a a static the performance of a static benchmark. Instead, we fix the agent architecture and we switch between models. If like your architecture can gain a lot from switching from a weaker model to a stronger model, then somehow your architecture is more future proof because like the weaker model tomorrow is might be as good as a stronger model today. Yeah, so we think like switching like between weaker and strong models can give you some like early signals of what will happen next year and give you some time to prepare your architecture. Yeah, so for Manus, like we often like do these kind of reveal like every 1 or 2 month, and we often like do some like yeah, do some like research internally using like open source models and maybe like early access to proprietary models to like prepare the next release like even before the launch of the next model. Yeah.
Yeah, it's a good observation. You can actually do testing of your architecture by toggling different models that exist today. Yeah, that makes a lot of
Yeah.
sense. What about best practices or considerations for format for storing data? So like markdown files, plain text, log, uh, anything you prefer in particular? I think obviously it's, yeah, how do you think about that kind of file
Yeah.
formats for,
Yeah.
yeah.
I think like it's not about like plain text or markdown, but we always like prioritize line-based formats because like it allows like the model to use like grep or like read from a range of lines. And also like markdown can sometimes cause some troubles. Models are trained to use markdown really well, and sometimes it will maybe for some model I don't want to say that name, but they often like output too many bullet points if you use Markdown too often. Yeah, so actually we want to use more plain text.
Yeah, makes sense. How about on the topic of compaction versus summarization? Let's hit on summarization. This is an interesting one that I've been asked a lot before. Uh, how do you prompt to produce good summaries? So, for example, summarization, like you said, it's irreversible. So, if you don't prompt it properly, you can actually lose information. The best answer I
Yeah,
came up with is just tuning your prompt for high recall. But how do you approach this? So, summarization, how do you think about prompting for summarization?
yeah, actually, like we tried a lot like optimizing the prompt for summarization, but it turns out a simple approach works really well. Is that you do not use a freeform like prompt to let the AI generate everything. Instead, you can define a kind of a schema. It's just a form. There's a lot of fields, and let the AI to fill them. For example, like here are the
Uh,
files that I've modified, and here's the goal of the user. Here's what I left off. And if you use this kind of like a more structured schema, at least like the output is kind of stable, and you can iterate on this. So just do not use like freeform summarizations.
Got it. Yeah, that's a great observation. So you structured outputs rather than freeform summarization to enforce
Yeah,
certain things are always summarized. Yeah, that
yeah,
makes a lot of sense. How about with
yeah,
context? How about with compaction then? And actually, I want to make sure I understood that. So with compaction, let's say it's a like a search tool. You have the raw search tool output, and would it be that would be your raw message, and then the compaction would just be like a file name or something? Is that right?
yeah. It is. It's not only about like the tool call. It's also like applied to the result of the tool. Like interestingly we find out that almost every action in Manus is kind of like reversible if you can offload it to the file system or an external state. And for most of these tasks, you already have a unique identifier for it. For example, for file operations, of course, you have the file path. For like browser operations, you have the URL, and even for search actions, you have the query. So it's already there.
Yeah. Okay, that's a great one, and just want to hit that again because I've had this problem a lot. So, for example, I'm an agent that uses search. I perform it returns a token heavy tool call. I don't want to return that whole tool message to the agent. I've done things like some kind of summarization or compaction and send the summary back. But how do you approach that? Because you might want all that information to be accessible for the agent for its next decision. but you don't
Yeah.
want that huge context block to live inside your message history. So how do you approach that? You could send the whole message back, but then remove it later. That's what Claude does now. You could do a summarization first and send the summary over. Um, you could send everything and then do compaction so that later on you don't have the whole context in your message history. You only have like a link to the file. How do you think about that specifically? If you see what I'm saying?
Yeah, I know. Actually, it depends on the scenario. For example, like for like complex search, for complex search, it's not just one query. For example, like
Yes.
you have multiple queries and you want to like gather some important things and drop everything else. In this case, I think we should use sub agents, or internally we call it agent as tool. So for the from the model's perspective, it's still a kind of function maybe called advanced search. It's a function called advanced search, but what it triggers is actually another sub agent. But that sub-agent is more like a workflow or agentic workflow that has a fixed output schema. And that is the result that returns to the agent. But for like other kinds of more simpler search, for example, just like searching Google, like we just use the full detail format and like append it into the context and rely on the compaction thing. But also like we always like instruct the model to like write down like the intermediate insights or key findings into files in case that like the compaction happens earlier than the model expected. And if you like do this really well, actually you don't lose a lot of information by
Yeah.
compaction, because sometimes like those like old tool calls are irrelevant after time.
Yeah, that makes sense. Um, and I like the idea of agent as tool. We do that quite a bit, and that
Yeah,
does make that is highly effective.
yeah,
But that brings up another interesting point about, and you reference this a little bit, agent-agent communication. How do you address that? So Walden Yan from Cognition had a very nice blog post talking about this is like a major problem that they have with Devon. So like
yeah,
kind of communication between agents. How do you think about that problem? And yeah, ensuring sufficient information is transferred, but not
yeah.
overloading, like you said, the prefill of the sub-agent with too much context. So how do you think about that?
Yeah, like at Manus, we've like launched a feature called Wide Research a month ago. Like
Yes,
it's
I saw
basically
that.
like yeah, internally we call it agentic MapReduce because we got inspired from the design of MapReduce. And it's kind of special for Manus because there's a full virtual machine behind the session. So one way we pass like information or pass context from the main agent to sub agent is by sharing the same sandbox. So the file system is there, and you can only pass like the like different path here. And I think like
Mm,
sending information to sub agent is not that hard. The more complex thing is about how to like have the correct output from different agents. And what we did here is like we have a trick for every time if the main agent want to spawn up a new sub agent or maybe 10 sub agent, you have to let the main agent to define the output schema. And in the sub agent perspective, you have a special tool called submit result. And we use constraint decoding to ensure that what the sub agent submits back to the main agent is the schema that is defined by the main agent. Yeah, so you can imagine that this kind of map reduce operation, it will generate a kind of like spreadsheet, and the spreadsheet is constrained by the schema.
That's an interesting theme that seems to come up a lot with how you design Manus. You use schemas and structured outputs, both for
Yeah,
summarization and for this agent-agent communication. So it's kind of like use schemas as contracts
yeah,
between agent, sub-agent, or between like a tool and your agent to ensure that sufficient information is passed in a structured way, in a complete way. Like we're doing summarization, you use a schema as well. Okay,
yeah.
fantastic. This is very, very, very helpful. I'm poking around some other interesting questions here. Any thoughts on models? Like, I think you guys use Anthropic, but do you work with open models? Do you do fine
Yeah.
tuning? You talked a lot about kind of working with KV cache. So for that, maybe using open models. How do you think about like model choice?
Yeah, actually, right now we don't use any like open source model right now because I think it's not about quality. It's about cost. We often think that open source model can lower the cost, but if you're at the scale of Manus and if you're building a real agent, which the input is way longer than the output, then KV cache is super important. And distributed KV cache is very hard to implement if you use like open source solutions. And if you use like those like frontier LM providers, they have more solid infrastructure for like distributed cache globally. So sometimes like if you do the math, at least for Manus, we find out that using like these flagship models can sometimes can be even more cheaper than like using open source models. And right now we're not only using Anthropic. Of course, like Anthropic's model is the best choice for like agentic tasks, but we also like seeing like good progress in Gemini and in OpenAI's new model. I think right now, like these like frontier labs are not converging in directions. For example, like if you're doing coding, of course you should use Claude, and if you want to do like more multimodality things, you should use Gemini. And OpenAI's model is super good at like complex math and reasoning. So I think for application companies like us, one of our advantages is that we do not have to build on top of only one model. You can do some like task level routing, or maybe even subtasks or step level routing if you can like calculate like if you can tolerate that kind of KV cache validation. So I think it's advantage for us, and we do a lot of evaluations internally to know which
Yeah.
models to use for which subtask.
Yeah, that makes a lot of sense. I want to clarify one little thing. So with KV Cache, so what specific features from the or yeah, what from the providers are you using for cache management? So okay, I know like
Mm,
Anthropic has input caching as an example.
yeah,
That's what you mean. Okay, got it.
yeah,
Um, cool. Okay, perfect.
yeah.
Um, cool. I'm just looking through some of the other questions. Yeah, tool selection is a good one. Um, Right. So you're talking about this. You don't use like indexing of tool descriptions and fetching tools on the fly based on semantic similarity. How do you handle that? Like what's the threshold for too many tools? Yeah, tool choice is a
Yeah.
classic. How do you think about that?
Yeah. First of all, it depends on the model. Different model has
Yeah,
different capacity for like tools, but I think a rule of
right.
thumb is try not to like include more than like 30 tools. It's just a random number in my mind. But actually, I think
Yeah,
like if you're building a we call it a general AI agent like Manus, you want to make sure those like native functions are super atomic. So actually, there
yeah,
are not that much like atomic function that we need to put inside the action space. So like for Manus, we right now
cool.
we only have like 10 or 20 like atomic function, and everything else is in the sandbox. Yeah, so we don't have to pull things like dynamically.
Yeah, good point. Actually, let's explain that a little bit more. So you have, let's say, 10 tools that can be called directly
Yeah.
um, by the agent. But then I guess it's like you said, the agent can also choose to, for example, write a script and then execute a script. So that
Yes.
expands its action space hugely without giving it like you don't have an independent tool for each possible script, of course. That's insane. So a very
Yeah.
general tool to like write a script and then run it does a lot. Is that what you mean?
Yeah. Yeah, exactly. Because why we are super confident to call Manus a general agent because it runs on a computer, and computer are Turing complete. The computer is
Yeah,
the best invention of human. Like theoretically, like an agent can do anything that and maybe a junior intern can do using a computer. So with the shell
yeah,
tool and the text editor, we think it's already Turing complete. So you can offload a
yeah,
lot of things like to Sandbox.
yeah. Okay, that makes a lot of sense, right? Um, and then how does Menace? So is are all so okay? Maybe I'll back up. You mentioned Kodak. With code agents, my understanding is the model will actually always produce a script, and that'll then be run inside a code sandbox. So every tool call is effectively like a script is generated and run. It sounds like you do some hybrid, where sometimes the model can just call tools directly, but other times it can actually choose to do something in the sandbox. Is that right? So it's kind of a hybrid
Yeah,
approach.
Yeah,
Okay.
I think this is super important because like actually we try to use entirely to use Kodak for Manus, but the problem is if you're using code, you cannot leverage like constraint decoding, and things can go wrong.
Um,
Yeah, but Kodak has some like special use cases as I mentioned earlier in slides. For example, like processing a large amount of data, you don't have to like pour everything in the tool result. Instead, you put it inside like maybe the runtime memory of Python, and you only get the result back to the model. So we think you should do it like in a hybrid way.
Got it. Allow for tool calling and use some number of tools, maybe 10 or something that are just called directly, some number of
Yeah.
tools that actually run in the sandbox itself. Yeah,
Yes.
perfect. That makes a ton of sense. Very interesting. Um, And then maybe how do you keep a reference of all the previously I guess you have, so you basically will generate a bunch of files. Oh, actually, sorry, maybe I'll talk about something else. How about planning? Tell me about
Mm.
planning. And I know Manus has this to-do tool, or it generates a to-do list at the start of tasks. Yeah, tell me about that.
Yeah, I think this is very interesting because like at the beginning, Manus uses that to-do.md paradigm. Like it's kind
Yeah,
of yeah, I don't want to use the word stupid, but actually it wastes a lot of turn, you know? Like back in maybe March or April, like if you like check the log of some Menace tasks, maybe like one third of the action is about like updating the to-do list. It wastes a
yeah,
lot of like tokens. Yeah. So right now we're using a more like structuralized planning. For example, like if you use Menace, there's a planner at the bottom of like the system. Internally, it's also kind of a tool called it's we implemented using the agent as tool paradigm so that like there's a separate agent that is managing the plan. So actually right now the latest version of Manus, we are no longer using that to-do.md thing. Of course, like to-do.md still works and it can generate like good results. But if you want to save tokens, you can find another way.
got it. Yeah. So you have like a planner agent, and it's more like for subtasks, it'll be more like agent as tool call type things.
Yeah,
Got
yeah.
it.
And you know, it's very important to have a separate agent to that has a different perspective. So it can do
Yeah.
some like external reviews. And you can use different models for planning. For example, like, oh yeah, sometimes like Grok can generate some very interesting insights.
Yeah. Well, that's a great one, actually. So think about like multi-agent then. And so, like, how do you think about that? So you might have like a planning agent with its own context window, makes a plan, produces like some kind of plan object. Maybe it's a file, or maybe it just calls subagents directly. How do you think about that? Like, and
Yeah,
how many different
I think
subagents do you typically recommend using?
yeah, I think this is also like depends on your design, but here at
Yeah.
Manus, actually Manus is not kind of like the typical multi-agent system. For example, like we've seen a lot of like different agents that divides by role. For example, like you have a designer agent or design or like programming agent, manager agent. We don't do that because we think like why we have this is because this is how like human company works, and this is due to the limitation of like human context. So in Manus,
Yeah.
Manus is a multi-agent system, but we do not divide by role. We only have very few agents. For example, we have a huge like general executor agent and a planner agent and a knowledge management agent and maybe like some yeah data API registration agent. Yeah. So we are very cautious about adding more sub agents because of the reason that we've mentioned before. The communication is very hard. And we implement more kinds of like sub agents as agent as tools, as we mentioned before, with
Yeah,
fixed schemas.
yeah, that's a great point. I see this mistake a lot, or I don't know if it's a mistake, but you see anthropomorphizing agents a lot. Like it's my designer agent, and I think it's kind of a forced analogy to think about like a
Yeah.
human org chart in your subagents. So, got it. So for you, it's like a planner and knowledge manager. A knowledge manager might do what? Like what will
Yeah,
be the
because
task of a
we have
knowledge manager? Like,
yeah, it's even like more simple. As we mentioned, like we have a knowledge system and Manus. What the knowledge agent does is that it reviews like the conversation between the user and the agent and figure out like what should be like saved in the long-term memory. So it's that simple.
got it. Yeah, okay, got it. It's like a, yeah, memory manager planner, and then you
Yeah,
have sub agents that can just take on like a general executor sub agent that can just call all the tools or
yeah,
actions in the sandbox. That makes sense. Keep it simple. I like
yeah,
that a lot. Right. That makes a lot
yeah,
of sense.
yeah,
Um, yeah. Let me see if there's any. There's a bunch of questions here, but we did hit a lot, so that's actually. How about guardrailing? Someone asked a question about kind of safety and guardrailing. How do you think about this? I guess that's the nice thing about a sandbox, but tell me a little bit about that, how you think about it.
yeah. I think this is very sensitive question because like you know if you have a sandbox that's connected to the internet, everything is dangerous. Yeah, so
Yeah.
we have put a lot of effort like in guardrailing. Like at least we do not let the information to get out of the sandbox. For example, like if you like got prompt injected, we have some like checks on like outgoing traffic. For example, like we'll ensure that no like token things will go out of the sandbox. And if the user wants to like print something out of the sandbox, we have those kind of um what we call it removing things and to ensure that no information go out to the sandbox. But you know
Yeah.
for another kind of thing is that we have a browser inside of Manus and the browser is
Mm,
very complicated. For example, like if you log into some like your websites, you can choose to let Manus to persist your login state, and this turns out to
mm,
be like very tricky because like sometimes
Mm,
the content of the web page can also be like malicious. Maybe they're doing like prompt injection. And this, I think, is somehow like out of the scope for an application company. So we're working very closely with those computer use model provider, for example, like Anthropic and
yeah.
Google. Yeah, they're adding a lot of guardrails here. So right now in Manus, every time you do some like sensitive operations, whether or inside the browser or in the sandbox, Manus will require a manual confirmation. And you must accept it, or otherwise you have to take over it to finish it yourself. So I think like it's pretty hard for us to like design a like kind of a very like well designed solution. It's a progressive approach. So right now we're letting the user to take over more frequently, but like if the
Yeah.
guardrail itself in the model gets better, we can do less.
Yeah. Yeah. How about the topic of evals? This has been discussed a lot, quite a bit online. If you've probably seen, Claude Code, they talked a lot about just doing less formal evals, at least for code, because code evals are more or less saturated, lots of internal dogfooding. How do you think about evals? Are they useful? What evals
Mm,
are actually useful?
yeah.
What's your approach?
Uh,
Yeah.
yeah. At the beginning, at the launch of Manus, we are using like public academic benchmarks like Gaia. But then,
Yeah.
like after launching to the public, we find out that it's super misaligned. Models are
Yeah.
architecture that gets like high scores like Gaia. The user don't like it. So right now we use
Yeah.
like we have three different kinds of evaluations. First of all, most importantly is that for every like completed session in Manus, we'll request the user to like give a feedback. We give 1 to 5 stars. Yeah, this is the
Yeah.
gold standard. Like we always care about
Got it.
like the average user rating. This is number one. And number
Yep.
two, we're still using some like internal automated tests with like verifiable results. For example, like we have like curated our own data set with like clear answers, but also like we still use a lot of like public academic benchmarks, but we also curated some data sets that's more focused on execution, because like most benchmark out there are more about like read only tests. So we designed some like executing tasks or transactional tasks, because we have the sandbox, so we can like frequently reset the test environment. So these are the automated parts. And
Yep.
most importantly, number three, we have a lot of interns. You have to use a
Yeah.
lot of real human interns to do evaluations on things like
Yeah. Yeah.
website generation or data visualization, because like it's very hard to design a good reward model that knows whether the output is visually appealing. Like it's about the taste. Yeah, so we still rely on a lot of
Yeah. Yeah.
of
Yeah.
human.
Perfect. Yeah, let me ask you. I know we're coming up on time, but I did want to ask you about this emerging trend of reinforcement learning with verifiable rewards versus just building tool calling agents. So like Claude
Mhm.
Code, extremely good, and they have the benefit because they built the harness and they can perform RL on their harness and it can get really, really good
Yeah.
with the tools they provide in the harness. Do you guys do RL? Or how do you think about that? Because of course, in that case, you would
Mm.
have to be using open models. I've been playing with this
Yeah.
quite a bit lately. How do you think about that? Just like using tool calling out of the box with model providers versus doing RL yourself inside your environment with your harness. Um, yeah, how
Yeah.
do you think about that?
Actually, yeah, I mentioned like before starting Manus, I was kind of a model training guy. I've been doing like pre-training,
Yes.
post-training RL for a lot of years. But I have to
Yes.
say that right now, if you have like in like sufficient resource, you can try. But actually, like we as I mentioned earlier, MCP is a big changer here. Because like if you want to support MCP, you're not using a fixed action space. And if it's not a fixed action space, it's very, very hard to design a good like reward. And you cannot generate a lot of like the rollouts and feedbacks will be unbalanced. So if you want
Yeah.
to build a model using like that supports MCP, you are literally building a foundation model by yourself. So I think like
Yeah.
everyone in the community, like model companies, they're doing the same thing. They're doing the same thing for you. So right now, I don't think we should spend that much time on doing RL right now. But like as I mentioned earlier, we are just discovering like exploring new ways to do like we maybe call it like personalization or some sort of online learning, but using like parameter free way. For example, like collective feedbacks.
Yeah. One little one along those lines is it the case that, for example, Anthropic's done reinforcement learning with verifiable rewards on some set of tools used within Claude Code. Have you found that you can kind of mock your harness to use similar tool names to kind of unlock the same capability, if that makes sense? Like, for example,
Oh,
like I believe they've obviously performed, it utilizes glob, it uses grep, it uses some other set of tools for manipulating the file system. Can you effectively reproduce that same functionality by having the exact same tools with same tool names, same descriptions in your harness? Or kind of how do you think about that, like unlocking um, Unlocking
Yeah.
the,
Uh,
yeah, right. You see what I'm saying? Yeah.
Yeah, I know the clear answer here, but for us, we
Yeah.
actually try not to use the same name because like it
Okay.
will like if you design your own function, you maybe have like different requirements for that function, and the parameters of the input arguments might be different. So you don't want to like confuse the model. Like if the model is trained on a lot of like post-training data that has some
Yes.
like internal tools, you don't want to
Yes.
to let the model to be confused.
Okay. Okay. Got it. Got it. Perfect. Um, well, I think we're actually at time, and I want to respect your time because I know it's early. You're in Singapore. It's very early
Yeah.
for you. So, well, this was really good. Thank you. We'll definitely make sure this recording is available. We'll make sure slides are
Okay.
available. Um, any parting things you want to mention? Things you want to call out? Calls to action? Um, yeah, people should go use Manus, but the floor is yours.
Yeah, I just want to say, everybody try this. We have a free tier.
Yeah, yeah,
Thank
yeah,
you.
yeah. Absolutely. Hey, thanks a lot, Peak. I'd love to do this again sometime.
Yeah, thanks for having me.
Yep.
Okay,
Bye.
bye.
Bye.